So in this video I'm going to go over the mechanics paper from June 2017, and it is, well, it's a kind of average difficulty, not some difficult bits. Certainly question 1 shouldn't have been difficult, although a few people did lose marks where they shouldn't have done. Okay, we've got the magnitude of I, and the formula we're looking for is impulses defined as change in momentum. I'm going to write it slightly more conveniently like this, but it's basically change in momentum, mv minus mu. So I'm going to put into this formula, we know that the mass is 0.5. Okay, the initial velocity v is, that's the final velocity. The initial velocity u is that, so the final velocity is 2i plus 3j. Take away 4j, which is the initial velocity. So the impulse, multiplying that all out, 0.5 times 2 is obviously 1i, and here we've got minus j times by 0.5, so that's minus 0.5j, and that's it. Well, it's not, is it? Some people just don't finish the question. I think most people know that a magnitude involves finding using Pythagoras on this, but some people forget to do it and therefore lose a couple of marks. Look, it's 1, 2 marks. So you look at the components, so that's 1 squared, and I don't tend to, the negative just means it goes downwards, so let's just save ourselves a bit of writing. It's just the actual magnitudes of the components that matter as well, so it's 1 squared, 0.5 squared, and that comes to 1.12. I will put the units in. One form of the units is Newton seconds. Could also have kilograms meters per second, but to be honest, they don't normally penalise lack of units, but I like to put them in there anyway. Of course, sometimes they ask for units as well, so it's a good habit to get into. Okay, so the angle between I and J. Well, this is, I was a little bit surprised by having marked some of these, that many, probably as many, got this wrong or didn't get full marks for this. I is this vector here, so which means it's going down in this direction like that, 1 across like that, and 0.5 down. And it says with the vector j, and the point is j is a vector which is going upwards. You can't take it with that down, because that's minus j. We have to give the actual vector that we want. So a lot of so we've got a right angle here. A lot of my students anyway kind of messed up there. Again, it's the same, lose 1 mark. So here's the angle here. So the required angle is going to be 90 degrees because we've got this right angle here, plus this angle here, which is the arctan of 0.5 over 1. Of 0.5 over 1. Work that out and we get 117 degrees. Okay, nice easy first question. Don't rush too much because I suspect that's what many people do and therefore lose because they want to get on to the more meaty questions later on. Okay, let's have a look at question 2. Okay, so question 2 is fairly standard work, energy and power. The first bit being power, and then you have to use work energy principle later in the question. We've got a truck carrying a trailer. No attempt is going to be made to draw a truck and a trailer here. It's given the resistances, which, and we know the angle. It's given the resistances, let's just be careful here. We've got the resistances, 200 newtons and 50 newtons. 200 newtons being on resistance on the truck, so that's 200 newtons on the truck, and 50 newtons on the trailer. And then we've got weights going down. of 900 G, because it's 900 kilograms, and 150 G. And what's happening is it's being pulled up by some driving force here. I think that's good enough. The one thing it's saying first of all here is it's going at constant speed somewhere here. So that means that it's in equilibrium. So it's going at 15 meters per second. That means that it's in equilibrium, forces up equals forces down. So resolving parallel to the slope, we've got the force upwards, which is up the slope, is F. It's going to be equal to all the forces downwards. Now I'm going to add these two together just to give us fewer terms. So that's 1050 G, but don't forget the component of that will be down the plane, so that needs to be sine theta on those. And then we've got plus the two resistances, which together are 250. Okay, so that gives me F is equal to 1050 G times by 1/9 plus 250, and that comes to 4180/3. That's the driving force. It wants the power, and there's a formula for that. The rate of doing work is force times the driving force times by the velocity. So that will be 4180/3 times 15, which is equal to 20900 watts. I could give it in kilowatts, I suppose. I don't think it matters, but I'll give it in kilowatts too. There we go. So that's the first part. The second part starts talking about something else happening, and basically what's happened then is they become disconnected. Right, so we've got the thing going off here. There's still a driving force, but now of course we've only got the 200 newtons driving down, and of course the weight of this is 900 G. Okay, and then there's a trailer kind of still moving upwards but being disconnected, so not being pulled upwards. So for part B, it's just a case of applying F equals ma, because what basically happens is that because it's not pulling anymore, there's not going to be a tension. There would have been a tension in the bar here, which is gone now. It's going to start accelerating. But at the instant where it does start accelerating, just after it breaks, nothing will have changed. The driving force will be as it was before. So that's quite important. So let's apply F equals ma. We've got the driving force, which we've worked out from before, 4180/3. And again, we've got the 200 acting downwards, and we've got 900 G sine theta. 900 G sine theta is equal to 900A. Okay, so working all that out should be fairly straightforward. Again, we know that sine theta is equal to 1/9, so we can sub in. I might as well do that now. We'll just put that 1/9, and that gives me A equals to, when I work all that out, 32/135, which is equal to 0.237 meters per second squared. Okay, now a little exam tip here. This is something that I think perhaps I ought to make clearer sometimes, is that would not get full marks, and it's a bit, I'll tell you why in a moment. It kind of goes against our kind of feeling of mathematics sometimes. I always try and tell people fractions are so nice in maths, and that's what we want to work with. I suppose those who do physics will be used to, right, working in decimals anyway. The reason why the fraction is not accepted here is because we've used g is equal to 9.8. So if we were to, we've used that in there, which is an approximation. So if we've used 9.8 in our calculations, we're implying that we think this is exact if we leave a fraction. So that's why it's not accepted, because it's actually, this is an approximate answer which we're given as a fraction, which is not allowed. Whereas an approximate answer given as a decimal to 3 or 2 decimal places is fine. Okay, so the last part, part C. So for the last part of part C, we're now looking at the trailer, and as I just mentioned earlier, the trailer is not going to just suddenly go downwards. Of course, its momentum is going to carry it going upwards up to a point here where it will have 0 velocity, and it wants you to use the to find the distance. I'm going to call it d, that it moves upwards. Okay. So the thing is here, you can't use F equals ma and solve that because it's very clear. It says work energy principle, so we can't do that. Well, what forces are on this, apart from gravity, of course? The only external force here is of 50 newtons, which is the air resistance. Okay, and then of course gravity, but gravity gets incorporated into the gravitational potential energy, so that's fine. So we don't have to look at that. Now, I tend to like to structure these questions into this. Basically, the work energy principle can be summarized as this: work done by external force, or forces sometimes. Occasionally you've got more than one force. Here we've only got one. If you use this, we've got to be, what people tend to mess up here is signs. They get the idea of what we've got to do, but mess up with the signs. We have to be careful. I always like to think, well, is the kinetic energy reduced here or is it increased? It's obviously reduced because it starts off here with a speed of 15 meters per second, and it's got a speed here of 0. So my delta KE is going to be whatever the kinetic energy is here, but it's a reduction, so hence a negative. Negative half of the mass of the thing is equal to, what's the mass of the trailer? Got all the way back up there, 150. So that's 150 times by 15 squared. Okay, and then obviously the potential energy will have increased because it's upwards. How much will it have increased by? Well, again, we've got this angle here, theta here. It will be d sine theta, but we know that sine theta is 1/9, so that's d over 9 is the vertical distance it's moved upwards. Okay, so that's plus mass, which is 150, times by g, 9.8, times by d sine theta, that's d over 9. Right, now, so definitely a decrease, definitely an increase of potential energy. Now, what we've got to be careful of here is, do we get the sign right in this bit? Because this is a resistive force. It's going to be taking away mechanical energy. If it were a driving force, then we would put a positive here, but we're going to put a negative. If it were adding energy to the system, mechanical energy to the system, we'd put positive, but it's taken away, so we need the negative sign there. And of course it will be work done is force times distance, that's minus 50d. Okay, so working each of these bits out, minus 16875 plus this bit here is equal to 490 over 3, d is equal to minus 50d. Rearranging this around a bit, we'll get 490 over 3 plus 50 d is equal to 16875. So dividing these two numbers together, we get D is equal to 79.1 meters. Okay, so fairly standard, but some students find them a little bit difficult, but fairly standard work energy power question for question 2. Just got to be careful. I think the last part is probably the trickiest. You've got to be careful with the signs when using work energy and principle. Okay, let's have a look at question 3. Okay, so the third question centres of maths questions. As these things go, this wasn't one of the hardest. I suppose the only thing you have to be careful of is if this has got double thickness, because it says the uniform lamina, this thing, is folded over. So think about it, that comes there. So we've got double thickness when we fold that over, because it's all going to produce this shape here. So, but that's actually quite handy, because all of these have got the same mass. Okay, different areas, but same mass, because this one's got double thickness. So if we talk about the ratio of masses, we just got 1, 1, 1, and then the total mass is 3. Right, let's call it x. Now that's a distance. It wants a distance from EF. Notice it doesn't want any other distance. To be honest, it will be easy to work out a distance vertically by symmetry anyway. So I'm just going to deal with the x bit because it hasn't asked for the y bit, and I think we're probably going to need it next question. So here we go. We put everything in there, and it should be okay. Well, let's do the easy ones first. This one here. Well, the length from here to here is 2a, so this has got to be a. And again, the length from here to for this part, that length there is a, but we've got to add it to the 2a that we've got here. So that's 3a. So the slightly more troublesome one is this one here. Well, bearing in mind it's a third, because it's a triangle, it's a third of the way. Now this is 2a, so this distance here is 2a over 3, but we're taking that distance away from 2a, so that's 2a minus 2a over 3, so that equals to 4a over 3. It's that distance there. Okay, because using the fact that it's a third from the length here, or 2/3 away from 2/3 of 2a is another way of looking at it, because it's going to be 2/3 that way of 2a. Just making sure that we're careful there, and that's x bar. So now all we have to do is use the formula sigma xi mi is equal to x bar sigma mi, or don't even have to quote it to be honest, but just for those who do like it to quote these things. So that's that times that, so that's 1 times a plus 1 times 4a over 3, that times that, plus 1 times 3a is equal to 3x bar. Now putting these over a common denominator, I'll get 3a plus 4a plus 9a over 3 is equal to 3x bar. So x bar is equal to, that's 7 plus 9, that's 16a, so that's over 3 times 3, so that's 16a over 9 as required. I think you'll agree, as these questions can go, this is not the most difficult, the first part. And then we've got something with a little thing in it in part B, but nothing too much. Part B, I've got a blown up version of it here. I had to get a diagram. It says it's suspended from C. Okay, so we have a line going with a vertical line going through the centre of mass, and the angle we're being asked for is this angle here. Let's call it alpha. Well, of course we know that this angle is 45, so we can just work this angle out and take it away from 45. Right, so we just need some distances here. Now we've already worked out this distance from here to here. which is 16a over 9. By symmetry, we also know this distance here, because it's going to be this line of symmetry all the way along here through this diagonally across. So the centre of mass vertically has got to be 16a over 9. Probably easier to write it there, which will help us construct our triangle, 16a over 9. Now that means that this distance here is equal to 2a minus 16a over 9, because we know the length from here to here is 2a. So that there is equal to 18a over 9. So take away 16, so that's 2a over 9 there. He's looking like 9, is 2a over 9 there. So the required angle, because we've got our right angle triangle here now, we're going to be taking it away from 45, okay, because this whole angle, as I said, is 45. Take away this angle here, which will be that opposite over adjacent, so that turns to 2a over 9, so it's arctan 2a over 9 over 16a over 9. Well, obviously that works out as 45. Take away arctan 1 over 8. I think this angle works out as something like 7 degrees or so, so I'm sure a lot of you have got that number there, but I'm going to smash it out in one go. So 45 minus arctan 1 over 8 yeah, 37.9 degrees. Okay, so question 4 I think is really nice and easy. A lot of people picked up some good marks here, especially earlier on. Particle, we're given a velocity and we're told it comes to instantaneous. That just means it's restful at one particular moment. So it's pretty clear what we need to do here. We've got v is equal to 0. You will not find much easier than this on M1, I don't think. We just got to equate this to be equal to 0. That factorises 3t to t equals 0, and looking at this we've got to have a 7 here and a 3 here, and both negatives. T1 is the smaller one of the two, so T1 is equal to 7 over 3 and T2 is equal to 3. So there you go. I'm not going to get much easier questions than that. Part B is not difficult though either, because we've got to find acceleration, we need to differentiate the velocity. So A is equal to dv by dt, so that's equal to 6t minus 16. So when t is equal to t1, which is 7 over 3, we've got acceleration is equal to 6 times 7 over 3, take away 16, which is equal to 14, take away 16, which is equal to minus 2. Be careful though, it talks about the magnitude of acceleration, so we definitely need a positive answer. So don't. You'll get away without putting units. I always put units. You'll get away without putting units, but you won't get away without dropping the negatives. So there we go. So that's pretty easy as well. Question C. Well, to get distance or displacement, we need to integrate the velocity, which in this case is 3t squared minus 16t plus 21. dt. Now I'm going to put limits in here. We'd have to be careful because it wants a distance. So we've got the distance is equal to, or the magnitude of the distance, if you like, is equal to. Now we can put limits in here because it doesn't change direction between these two times at once. Within this, we'd have to be. You couldn't generally apply what I've done here because you'd have to allow. Because, for example, if something goes that way and then turns back again, and it wants the distance travelled, then you're not going to get the answer by doing this because of the change of direction. But if it's going in the same direction between two things, in fact in this case I think it's going this way, but there's no change of direction, we've got two different displacements, then of course the distance will be the difference between the two. So I'm going to put limits in, but do not think you can apply this in all cases, only because I know it's not changing direction. So that's 3 to 7 over 3, or 3t squared minus 16t plus 21 dt. So that equals, that's t cubed minus 8t squared plus 21t, between 3 and 7 over 3. And putting the limits into that, I'm going to do it this way by considering it term by term. So we've got 3 cubed minus 7 over 3 cubed, and then take away 8 times 3 squared, take 7 over 3 squared. When there's lots of terms, I often find it quicker and more easier to separate the terms like that. Anyway, when we do that, working that out, we get the answer minus 4 over 27. But of course, again, a bit like last time, we need, I probably was wrong to put magnitude in there. But anyway, we need the distance between the two is equal to 4 over 27. Put the modulus in the wrong side as quickly, should have put it there, shouldn't I? But anyway, never mind. It's clear what we're doing. So that's 4 over 27. Okay, now part D. Show that P does not return to O. Now remember, we've got displacement is equal to the integral of V dt, and we've already found that to be 3t squared minus 16t plus 20 plus, no, that's wrong. We're integrating this, we get that as t cubed minus 8t squared plus 21t plus c, but c equals to 0 because t equals to 0 when s equals to 0. So we can skip that thing here because it's clearly starting at the origin. So there's no c here. So when s equals to 0, we get t cubed minus 8t squared plus 21t equals 0, which is t times t squared minus 8t plus 21 equals 0. Of course, t equals to 0 is at the start, so we knew that anyway, but it does not return to the origin. So this must have no solutions. So you can use a discriminant if you want. That's the thing that's often in the mark scheme. I'm going to complete this square because I like doing things to something nicer really. Equals to 0. That's t minus 4 squared minus 16 plus 21 equals to 0. T minus 4 squared plus 5 equals to 0, which is so it doesn't solve. That's got no solutions. No solution. Thinking about it, I might restate this a little bit. What I might do is do this, considering that maybe I should have used discriminant anyway. That's equal to 0, which is greater than 0. So it never goes back to the origin. But we can use discriminant as well. Okay. But for those who say, oh, it doesn't say that in the mark scheme, it does say or equivalent. I just want it to be different. But discriminant's fine. Okay, I'll do, so just basically just say b squared minus 4ac. So we just say minus 8 squared minus 4 times by 1 times by 21. And that gives us 64 minus 84, which is minus 20, which is less than 0, so no real root. So that's I suppose, a more obvious way of doing it. Okay, right, I think we will do the other three questions in another video coming up. Okay, thanks, bye.